When you have data on two quantitative variables, the easiest way to graph your data is to make a scatter plot. Now, a scatter plot is very useful for seeing if there's any kind of an association between the two variables that you're looking at. Now, when you make a scatter plot, you should always start with the title that indicates what the scatter plot is about. Then you should have two axes, usually your x-axis and your y-axis, but you don't have to label them that way. You can label them with more descriptive names and make sure that you have your labels on your axes, and then scale your axes appropriately. Okay, so title, axes with scales and labels, and then in here we put our joint observations on the two variables we have. So for instance, this point right here would correspond to a value for this variable that corresponds to this place on the scale, and for this variable to that place on that scale. And you can plot all of your data points. But you need two values for each observation that you have. You need to have a value for this variable and a value for that variable for each of your observations, or you cannot do this kind of a graph. Now, it's not always necessary to differentiate between the two variables that you use, but in some situations it's important that you do. If you want to use one variable to explain or predict the behavior of another, you have to put the explanatory variable on the x-axis, and you have to put the response variable, the one we're trying to predict or explain, on the y-axis. And that's a very important distinction that will come up when we're working with best fit lines in a little bit. Now, when you see a scatter plot, you should be able to describe what you're seeing, and the sorts of things that you should describe when you're talking about a scatter plot are the basic things. Remember, data equals smooth plus rough. And in the case of a scatter plot, the smooth would include things like its form. Does it generally follow a straight line, or is it curved, U-shaped? Describe the shape of the scatter plot just in general terms. That would be its form. Talk about its direction. Is it positive, that is rising to the right, or is it negative, falling to the right? And strength. Less scatter around that basic form indicates greater strength. Those are the three things that generally can make up the smooth of your data, the general overall pattern. And then you want to indicate if the plot contains any apparent outliers, any points that stand apart from the bulk of the data, any influential points, which might affect your overall point of view about the form and strength of the association you're looking at, and then any gaps, clusters, or other unusual features in your graph. So those would be the rough. So data equals smooth plus rough. Smooth is form, direction, and strength. Rough would be outliers, influential points, and any other unusual features in your plot. In this particular plot up here, if we were to describe it, we would say that the scatter plot shows a moderately strong positive linear association between your two variables. And in any particular situation, you want to include in that description the context of the data that you're looking at. So you definitely want to include the names of the variables. So here are some examples of how that might work. Here is some data that I got from a local real estate website. I looked at house sizes in square feet and listing prices in thousands of dollars for 7 homes for sale in the 28715 zip code on September 27, 2015. And these are the data. These are the size values that I found in the listings, and then these are the prices I found in the listings. And what I did, I made a scatter plot where I have listing price versus house size as my title. Over here on the x-axis I have size in square feet. Up here on the y-axis I have price in thousands of dollars. And then I scaled my axis for size from 1,300 to 3,000 because the smallest value I have for size is 1,306 square feet. The biggest value I have for size is 2,990 square feet. So I just made my axis run from 1,300 to 3,000, and that would capture all the data and give you a pretty good idea about what the range of the data are just by looking at the axis. And then on the vertical axis, excuse me, my lowest value And my price is 170, and my highest value is 294. So I made my axis go from 170 to $300,000. And then I plotted my 7 points here. And then here's my interpretation of the scatter plot. The scatter plot shows a moderately strong, positive, that is rising to the right, linear association. These follow basically along a straight line. Association between listing price and house size for 7 homes for sale in the 28715 zip code on September 27, 2015, with no apparent outliers or influential points. So you can usually dispose of a description of a scatter plot in one sentence. If there are influential points or other unusual features, you might want to take an extra sentence or two to talk about them. But most of the time, you can describe a scatter plot in one sentence. Just make sure you have the form, direction, and strength of the association that you're looking at, and then have your variables. And so that's the what, and then here's the who, the 7 homes for sale, and the zip code on that date, and then here's the rough. So we've got the smooth and the rough all in one sentence. Here's another one. We have runs allowed in games won for 15 teams in the National League during the 2015 baseball season through September 27, 2015. Over here I've got the data, runs allowed, and then wins by the teams. And I've got in my scatter plot, I've got the title, games won versus runs allowed. I have runs allowed on the horizontal axis, which runs from about 500 to 820. And then I have wins on the vertical axis, which runs from about 59 up to about 98. And here are the points that I plotted in my scatter plot. And this scatter plot shows a strong negative linear, or very slightly curved perhaps, association between games won and runs allowed in the National League during the 2015 baseball season through September 27th, with no apparent outliers or influential points. Now it's possible at this point right here, if we were to take it away, it might make the rest of the scatter plot look a bit more linear, and so it might have a slight influence on our perception of the straightness or curvature of this plot. So in that sense, this might be a mildly influential point. But influential points usually make a significant difference when you include them versus taking them out. It makes a big difference in terms of how you perceive the scatter plot. And this doesn't seem to have a very major effect, but it does have a minor effect. And here's the third example. Here we've got errors committed and games won for 15 teams in the American League during the 2015 baseball season through September 27, 2015. Here I've got errors for the 15 teams and wins for the 15 teams. My scatter plot has a title, games won versus errors committed. I put errors on the horizontal axis, and I put wins on the vertical axis. And then I have my scatter plot for the 15 teams. Now you might see that there are only 14 dots in there. It's because right here there were 2 observations that coincided. You notice here there were 2 teams that had 85 errors and 90 wins. And usually when you have repeaters in any particular position in the scatter plot, you put a circle around it to indicate that there are 2 values there, or 2 observations there. Okay, now this scatter plot shows a weak negative linear association between games won and errors committed for the 15 American League teams during the 2015 baseball season through September 27th. With 2 apparent outliers, we have one here at 115 and 84, and here at 117.65, and was almost hiding away down here in the corner. If we were to take this one away, the general relationship that we would see would be fairly positive, maybe not very strongly positive, but weakly positive. Whereas if you include this, it makes the overall perception of this to be a negative relationship. So this point is having some influence here. If we take that out, our perception of the general relationship would be somewhat different. I mean, significantly different, I think, in terms of like if including it makes the relationship look negative, taking it away makes the relationship look positive. But in either case, the relationship is weak. There's a lot of scatter here. It's not a really clear form, so it's a weak relationship regardless of whether you include this point or not. So remember, when you are describing a scatter plot or drawing a scatter plot first, you always want to have a title. You want to have axes with labels and scales, and then you put your points in. If you have repeaters, put a circle. And then when you're describing the scatter plot, discuss the form, the direction, and the strength of the association that you see between the two variables, and then have the context in there. And then if there are any unusual features like apparent outliers, influential points, etc., include that in your description.